In this video, I'm going to walk you through lesson 10 of unit 7.1. Okay, so we left lesson 9 with adding heat to water and figuring out that there was no new substance created. We know this because we did the density test, and the liquid that was kind of forming on the tube and in the flask ended up being water. And so we realized that no new substance was made. And we navigate into this lesson by having a quick discussion about why we're doing this. So here's the slide that will support you. Remember, we'll reflect back on Dalton's articles. And we did the heat adding to the water, but now we're going to do the electricity. And we talk about what's this going to help us answer? What kind of data will help support or refute these ideas? And remember, we're talking about what happens to these particles when a new substance is made. Now, before we get any deeper, we need to just make sure, if you didn't get there in lesson 9, really revisit the ideas of phase changes. Now, this should have been developed in earlier grade levels in earlier units, but water can change from a solid, from a liquid to a gas. And so basically we were collecting water vapor that was turning back from a gas in the bubbles back to liquid. And so that's what was happening. No new substance was made. We were just seeing a phase change. Okay, but maybe electricity will give us a different result. So we prepare our notebooks to record some observations. Here's the slide to do that. They're going to add the title, Adding Energy to Water with Electricity, to a new section of their notebook. And then we're going to observe the setup and how we're capturing some gases in the test tubes for the electrolysis apparatus. Now, this is very important that you have this set up way before students come in. I would probably even set it up the day before and capture some of the gases created by the electrolysis apparatus. First of all, to make sure it's working properly, but you're going to need a lot of hydrogen tubes and oxygen tubes throughout the day. Depending on how many sections you have, you want to have extra. Just assume you want to do 2 flame tests for each test tube per class. So collect as much gas as you need accordingly. Here is a reference sheet on how to set up the electrolysis apparatus. And you can see here are the materials that you're going to need. Basically, you're going to set up something that looks like this. You're going to put salt water in a beaker. These are 2 test tubes with some wire that's going into each. The wire is a particular type. It is a stainless steel electrode wire. There's other machines that you can buy that are very expensive that will do this and probably more efficiently than this. This is basically the cheap way to build an electrolysis apparatus. When you connect it to the batteries, and if you need to connect more than one battery, you can kind of stack them. They're 9 volts, and so you can see how they're attached right here, or you can do one. And so this will go faster than this one, but you will see that, well, you can't see here, but little bubbles are going to start coming off these electrodes and filling these tubes. And once you've captured enough gas, you can put a stopper in it, and then they'll label it A and B for your hydrogen and your oxygen. And then you should be able to do a flammability test. There is a video if you need more guidance right here. It's on YouTube. It shows you how to set it up. I would set this up the day before, practice, capture some gas, and then be really ready to do it in front of students. But this is a lot of setup, and a real quick moment, but it's pretty cool, and the students love it because you're going to make a pop with that hydrogen gas. And make sure you have more than one tube because they're going to want to hear it more than one time. Okay, so we look at this apparatus, we look, oh, there's bubbles coming off of these wires. We notice one tube is filling up more quickly than the other. Students may realize, because we know a lot of them know water is H2O, and that the hydrogen is filling up faster than the oxygen. Don't tell them this if they don't bring it up, but a lot of students in 7th grade will know the formula H2O. And so there's going to be double the hydrogen than there is the oxygen. And we consider if these gases are made of the same particles produced from heating water. So don't give it away too early. We're going to do some considering. Here is the slide to help you. They're going to turn and talk and ask and talk about, do you think that the test tubes have the same type of gas? How can we figure that out? And so we test the gases using the flammability test that we did in earlier lessons. Here is a video to support you on that. If you're not allowed to have an open flame, you can just use this video as an alternative. And then we record the results in the data table. And so the data table is very simple. We're just going to have observations, gas A, gas B. The more gas is going to be your H2, the hydrogen, gas A. This one's going to have a pop. And then gas B, the oxygen, this one's going to have a glowing flame. It can reignite a wood splint that has been blown out. And so we use those common gases handout. This comes from lesson 5. We've already looked at this before. So hydrogen, you can see, will increase a flame or will cause a glowing ember to burst into a flame. So you can try either one of those, putting a flame in, or blow it out and stick in the glowing ember, and it will ignite again, and that proves that it's oxygen. And then the hydrogen, if you look, where is it? Right here, will increase a flame and can create an explosion. So it's not a real big explosion, but it's a pop and you can hear it. But do practice this so you're not scared before students are in the room. It's not going to hurt you, but it does give you a little startle. So practice before students come in. Okay. And then we revisit our class poster. It looks like this. This is the one where they were using those manipulatives, the dots, and trying to give ideas about what is happening to these particles when a new substance is made. And we're going to kind of revisit this and wonder, did any of these things happen here? Well, obviously, some of the particles are splitting apart. And so if students cut some in half, or they showed the third of them, that is going to be supported, that the particles here, the water particles, are actually breaking apart. Okay, and so we connect mass data. This was collected by scientists. We're not going to collect the gases in a closed system, but scientists did do this, and they found that the mass before adding the electrical energy was the same as the mass after the gas was produced. And so that gives us some more evidence that we can compare to our system, and that tells us that, well, it's the conservation of matter again, that the same particles that make up water are the same particles that are in those test tubes, and the same amounts. Okay, so now we're going to construct an explanation using evidence and reasoning again. So you can do a CER, or you can do the paragraph format. Remember, they practice that in lesson 9. Wherever you're at with that, they're going to do a constructed explanation. Here is the slide to help you. And when they're going to answer the question, when energy from a battery was added to water, were the gases produced by this made of the same particles as those produced from heating the water? And so they're going to need to make a claim if it was the same or different. You might want to get that claim evidence reasoning poster back up. Evidence is, well, the flammability test was obviously different. And then key ideas from our poster to support our explanation. Now there is an answer key, and this talks about what you're going to look for. This is claims. So now they're going to make the claim on their own this time. The last time it was given to them. We definitely need evidence here that is listed, and some reasoning key model ideas. Now it's going to look different than this. And if you are still using the graphic organizer of a CER, that's fine. But eventually we want to push students to be writing arguments with evidence in a paragraph. So that might not happen in 7.1, but that's obviously where we want to push them by the end of middle school, so they're ready for high school. All right, that's lesson 10. Let's talk about materials prep in the next video.